All right, in this one, we're going to use the tool within Chem 101 to write a complete ground state electron configuration. So ground state means we got nothing excited, which we are going to be almost impossible to predict. So ground state is what we can write, and complete means we're not using a noble gas to shorten it. We will get there, but here we want to work through a complete one. Now we're looking at arsenic, which is AS. We can find that it has 33 protons, which means 33 electrons. So that is what we're going to be working with to build our electron configuration. So let's use our tool. So first thing we have is n equals 1, L equals 0, which is an s orbital. So we're going to say 1s2. That's our first one. Then we go to 2s, and there's 2 electrons in that. So there's 4 electrons. Now we go to 2p, and there's 6. Remember, if L is 1, then we have -1, 0, and 1 with 2 electrons in each. Next, now we've filled the second. So we've filled n equals 1, we filled n equals 2. Now we're up to n equals 3. So we're going to start with a 3 there. Again, s orbitals, which hold 2. Then we're going to go to p orbitals, which hold 6. So we're up to 18. Now, this is where it gets interesting, right? So 3 has L equals 0, which is S, L equals 1, which is P, and L equals 2, which is D. So we have 3 D orbitals, which has -2, -1, 0, 1, and 2, so it can hold 10 electrons. But when we saw our energy, what's lower energy, we actually see that the 4s orbital is lower energy than the 3D, and you can use that diagonal type drawing if that works for you. So we're actually going to jump up to the 4s2, and then we'll do the 3d10. Now we're at 2, 4, 10, 18, 20, 30 electrons, and we have 33 to work with. So the next thing after 4s is 4p, and we don't just write 6, we write 3, because that's how many we have left. Now I think Chem 101 may give you credit if you do the 3d10 before the 4s2, but as we're working through this, it's good to remember the 4s comes first. Hopefully, if it helps you to remember. And we keep adding letters because we're adding additional L, and we're adding additional M sub Ls. So 5 will have a D and an F. Now it could keep going, but we don't see that on the periodic table. So we're gonna stop there. We could go to 6, but remember, we can look at it this way. So it actually goes 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and then 5s, and then next would be 4d, and then 5p, and so forth. So that can be a helpful tool to remember the order. Or you can use the periodic table like we learned in class.